All right, so the third skill that you're going to need, which is a really simple skill, is determining whether the p-value is what we call significant, okay? So each test, each hypothesis test is assigned what's called a significance level, and it's called the alpha. Now, I'm not going to go into too much detail right now, but there's a lot to understand about this alpha if you're going to be a researcher, okay? And this is the Greek letter alpha, so we call it, it's, if you want to spell it out, it's alpha. But this is the Greek letter alpha. It is the lowercase letter a, the first letter of the Greek alphabet, kind of like our lowercase a, only they call it alpha. Okay. Usually alpha is set at a number like 0.10 or 0.05 or 0.01. Okay. And so you'll typically see alpha being equal to one of these numbers. Okay. And it's called the significance level of the test. So typically, if the p-value is less than, smaller than, whatever the alpha is, then we say that the p-value is significant. However, if the p-value is greater than alpha, then we say that it is not significant. And that's pretty much it. So, we calculate our test statistic, then we plug it into NumWorks, we get a p-value, then we compare our p-value to whatever the alpha is, the significance level. And if the p-value is less than the alpha, then we say that the p-value is significant. If the p-value is greater than the alpha, then we say that it is not significant. Okay. There's only one more thing I want to show you right now. I'm going to go ahead and do it in this video. We're going to identify how to convert a level of significance, which is this alpha. We're going to learn how to convert the alpha into a confidence percentage, like from a confidence interval. All right, so to convert a level of significance or alpha into a confidence percentage, like for a confidence interval, okay? For a left or a right tail test, what you're going to do is you're going to take the alpha and you're going to double it. You're going to multiply it by 2, then you're going to subtract it from 1. This is now going to be a decimal value and you're going to turn it into a percentage. So for example, if I have a left tail test and alpha is equal to 0.05, then what I'm going to do is I'm going to do 1 minus 2 times 0.05 is 0.10. So 1 minus 0.10 is 0.90, and 0.90 is the same thing as 90%. So if alpha is 0.05 and it's a left tail test, that's the same thing as a 90% confidence interval, 90% confidence percentage. Suppose it's a right tail test, and I told you that alpha was equal to 0.01. Well, then we would do 1 minus 0.02. We want to take our 0.01, multiply it by 2, and we get 0.02. 1 minus 0.02 is 0.98, and 0.98 as a percentage is 98%. Okay. Now for a two-tail test, suppose it's a two-tail test, and what we're going to do is we're not going to double the alpha. We're just going to do 1 minus alpha and then turn it into a percentage. Let's say that alpha is equal to 0.01. Then we're going to do 1 minus 0.01, which is 0.99, and then that's going to be 99%. Okay? And so if it's a two-tail test and alpha is 0.01, that's the same thing as a 99% confidence interval. Okay? And that's all I have for you for this particular lesson. In the next set of lessons, we are actually going to do hypothesis testing.